Hello out there dear friends, and welcome to this video today in our channel. In today's video we shall be looking at one of the best ways in which you can use the Inference booklet inside the chemistry laboratory uh, to refer organic compounds or to refer inorganic compounds after you must have done your analysis and experiment. So guys, stay tuned and watch the video from start to finish, because at the end of this video you shall be able to use any Inference booklet you encounter so well. So guys, don't forget to like the video and subscribe to the channel. Let's get started. Friends, as you can see, this is the book I have. The name of the author is that's for Chungwa. Okay, this is the name of the author. Then you have advanced level quantitative and qualitative analysis. Then this is the 4th edition. So guys, there are other Inference booklets out there that you can get. Okay, this is not the only one you can get. You can get others, but the way to use them is the same. Okay, so just take and you try to read through it. Okay, now guys, let me start opening the page. Okay, let's just start opening the page and see. So as you can see, these are the various colors that you might refer to, and on this other side you also have colors, but I won't advise people to rely on these colors. Okay, but because they can be misleading sometimes. They can be misleading because this is just a printed color. The colors have just been scanned and pasted. Okay, so you shouldn't rely on them. So we are opening. I'm taking you to the content page. Okay, the content page, because it's very important. That's where most students always reach there and they don't know what to do. Okay. Sorry. So guys, this is the first one that we have the table of contents. Now they've given me that NB, that in this table and in the book, that's this W prime out means what, with or without, right? Good. So you can take your time to read all of this. Then this is where the content starts. You have quantitative analysis, that's page 21. Then volumetric analysis, page 22, and so on and so forth, guys. So you just take your time to go through all this. Then in the section we have chemical kinetics, page 40, and so on. Quantitative analysis, you have generalities on quantitative analysis. Then you leave from there. Now you have these stuffs here. Then guys, the most important, where you're going to have majority of the tests coming from, this is it, where you have this inorganic reactions. That is part 3B, inorganic reaction, page 57. So guys, let me just repeat it, because one of my audience said it as a comment. Okay, she was asking the question that how are you supposed to know if the source, that's which of the salt provided is inorganic, which one is organic. So friends, generally speaking, the first two salts, because in the lab they're going to give you 3 salts to analyze and come out with their identities. So the first 2 salts in the laboratory are going to be inorganic, then the last one is going to be organic. Again, the first 2 salts you have will be inorganic and the last salt is going to be organic. So what you simply do is that when you start with the first salt, right, the first salt which is inorganic, you are going to open to the page where you have inorganic. Okay, open here where you have inorganic. But before then, guys, I think we should look at the flame test. Because most of the questions are going to start by asking you to carry out a flame test on the portion of the first and second salt, or the first salt or the second, any of them. So guys, as you can see, under these generalities on quantitative analysis, page 45, under question 7, right, under the 7 of them you have flame test, right, which is page 52. So I think we should open to page 52 and see. So open. So guys, I've opened it. Okay, this is page 53, as you can see, but the page 52 starts from here. This is where it starts. This is page 52. All of this is a flame test, please forms cover of the book, that and that, all of those things. So guys, this is where we are. This is where we actually have the flame test. This is it. These are the various cations present, and these are their flame colors. Like you can see, this is lithium plus white. That's the lithium ion. You have carmine, in bracket you have deep red with bluish tints and darker than crimson. Then this is strontium 2+, right? then the color is crimson. In bracket you have bright deep red. Then you have calcium 2 plus, you have brick red, you have sodium plus, which is persistence golden yellow, you have barium 2 plus, which is apple green, copper 2 plus, you have bluish green, potassium plus, you have lilac or purple true blue glass, and so on and so forth. So guys, this is how you practically open it. Okay, so each time you're doing your flame test, you just go to your Inference booklet and you open to the flame colors, open to them. Oh, okay, friends, I believe that we know a bit about the flame test now, right? Good. Okay, now let's assume that we want to test for the presence of the chloride ions, right? Either the chlorides or the bromide or iodide ion. So and we know the reagent of choice, the reagent in which they are going to ask us to add is silver nitrate. Sometimes they can ask us to add lead nitrate, okay, but the observations are not going to change that much. All right, so let's say that the reagent is a silver nitrate, right, the inorganic salt. So I'll simply come to where I have inorganic reactions here, right? And keep in mind, guys, that all these reagents here have been arranged in alphabetical order. Okay, they've all been arranged in alphabetical order. So that's why the first reagent you're seeing all of them are starting with A, right? The next one is B, and so on and so forth. C. Good. So they have all been arranged in alphabetical order. So I want to look for silver nitrate, and silver nitrate, guys, starts with S, right? S. So I'll simply keep opening because here is C, so I have to open and go backwards. Here is I have C again, so I believe the silver nitrate, guys, it starts with what? S, not C, please. It starts with S. So I'm looking, this is I, this is L, this is M, this is Q. No, it's not found there. Alright, because here is Q, here is O, here is N, here is M, so it doesn't lie there. So I'll keep looking for it. This is P, right? This is P. So good. This is what I have, guys. This is what I have. So this is where I have the S. Now there's some trick you have to put in place. The first S, guys, as you can see here, is what? Silver nitrate solution with or without dilute nitric acid or ammonia solution. That now, guys, this is the one in which we are interested in. All right, because the always you should add silver nitrates and stroke what? Dilute nitric acid, right? This is here even. This is here. You have silver nitrate and what? And the nitric acid. Then here you have with or without ammonia. So in our case now, it is what? Without ammonia. Now let's look at the next. We have silver nitrate slash what? Dilute nitric acid, or what? We have sodium we have sodium thiosulfate or potassium cyanide. So this is not what we are going for. Okay, we rather go for the first, which talks about silver nitrate with dilute nitric acid. So guys, and the page here is page 78. So we'll simply open our page 78. We'll try to open the page. Open page 78. Opening that. So friends, as you can see, this is it. I have it here. This is AQ silver nitrate with or without dilute nitric acid, ammonia, that and that. So this is it. So now this is the table in which we are now going to refer it to. So guys, and we all know that for chlorine, right, chlorine is going to give us a white precipitate, right, which is insoluble in excess reagent. Then bromine gives us a pale yellow or a cream white precipitate. Then iodine gives us what? A yellow precipitate. So we are going to be looking at it. We have white precipitate, right? White precipitate form. So this is, let's assume that the salt was a chloride salt. Okay, the salt had chloride ions in it. So as I'm seeing white precipitate, I'm going to start looking here. Effervescence, dilute, no. So I expect to see what? Chlorine, right? Chloride ions. So white, we have cloudy precipitate. Precipitate dissolves in dilute nitric acid. No, the precipitate in this case does not dissolve. Okay, it does not dissolve. So this is not what is going to give me my answer. In this case, I have what? Still white precipitate. This is how the table continues. Then the B part says what? No effervescence with this. That's perfect, because no effervescence is going to be evolved, right? In other words, guys, no gas is going to be evolved during the reaction of silver nitrate and the chloride salt. Okay, no effervescence will be evolved. So I have no effervescence involved with dilute nitric acid. Good. I have white precipitate form, right? Insoluble in dilute nitric acid. Perfect. This is what I'm talking about, right? Turns purple gray in bright light or white precipitate. So guys, what I'm simply saying is that in your observations, right, in your observations, this is where we have full observations, because you'll be writing but full observations, not major observation, guys. We'll be writing full observations and not major observation, because the exam is just going to give you observations and inferences. So if it's a chloride ions, that is, if you add nitric acid and you see white precipitate which is insoluble in excess reagent, you are going to come here under observations. You copy all what you have here, copy it all, okay? Copy white precipitate formed insoluble in dilute nitric acid, then turns purplish gray in bright light, or white precipitate dissolves in aqueous. That, okay, you are going to copy all what you have here, though you did not give time for the precipitate to turn gray brown in bright light. Okay, you did not give time. Okay, you didn't give time, so you are going to come here and copy all what you have here. Then under the inferences, chloride ions present, right? Insoluble in silver chloride, insoluble in silver chloride. That's insoluble silver chloride precipitate. You write down the equation, and you also write everything you have here. Okay, write everything you have here, everything. That is to tell you that these are the inferences. You simply copy all what you have here, all, guys, all the inferences you have here. You copy all the inferences. Likewise, you copy all. Then now the next question might want you to carry out another test that is shown by only chloride ions. You see that that in this case now, if we added but excess of ammonia. Let's assume that we added but excess ammonia, right? Excess ammonia. Good. You see that it is going to turn purplish gray in bright light, or white precipitate dissolves in that. But if we're adding but nitric acid, therefore we're going to have this. So our advice you put to write all of this, okay, to copy all of this. But if you don't want to copy that for ammonia, no problem, okay, since you were adding but excess of nitric acid. If you choose not to copy that for ammonia, no problem. If you want to copy that for ammonia, fine. But since you are using but nitric acid, okay, since you use but nitric acid, you added but excess nitric acid, I suggest you copy white precipitate formed insoluble in dilute nitric acid, and there. Then you come under the inferences, chloride ions present, insoluble in silver chloride precipitate. Then you write down the equation. Then yes, good. So guys, this is what you're going to have. Good. Now, what will happen if instead we saw a pale yellow or a cream white precipitate? Okay. Now we are simply going to come under this number 2. What do we have here, friends? What do we have here? As I was saying, we have cream or yellow precipitate, right? Good. So we are simply going to come here where we have cream or yellow precipitate. Perfect. This is for the bromide ions, right? Good. So we simply come under full observation. This is where you're going to write observations. Full observations. You have cream or pale yellow precipitate, which is insoluble in dilute nitric acid formed, turns green or dark in that. You copy it, okay? Copy it under observations. Then under inferences, bromide ions present insoluble in a silver bromide precipitate. You write the equation. The equation is so important. It's going to give you a mark, okay? Write down the equation. So this is what you're going to write, guys. Then likewise for iodine, where you see a yellow insoluble in excess reagent, you simply know it is iodine. You do the same, you write everything here. So guys, this is it for silver nitrate. Now, what if you have been asked to add barium chloride? I told you guys that barium chloride is being used to test for the sulfate and sulfide, right? But sometimes it also gives a positive test with a thiosulfate ion. So guys, let's go under barium chloride. Let's say we've been asked to add our reagent, that's barium chloride. We'll simply come under our inorganic reactions. Inorganic reactions. We look for where we have barium chloride. So as you can see, guys, this is barium chloride, right? This is the reagent barium chloride. This is it. Barium chloride with or without dilute nitric acid. With or without dilute HCl. Good. So the pH is pH, it's 8, right? And it's under inorganic reactions. Take note, inorganic reactions. You simply open to pH 88, inorganic reactions. We open. So as you can see, guys, this is page 88 I have here. This is page 88, as you can see here. Then this is it, barium chloride with or without dilute HCl. Good. Then guys, since let's assume that, okay, now all we expect to have using the barium chloride, we expect to have a white precipitate, right? A white precipitate. So we are going to come here, white precipitate form, right? Good. So it is either any of these ones here, any of these ones cutting from here, or what? It's either any of them that we are going to take. Then we come now to, okay, now the table has been divided again, just that this one is not too clear, but at least I'll bring it up so that people can see it very well. Good. So if you can see very well, you'll see that this is what insoluble in excess dilute HCl, right? In the case of what the sulfite, the sulfate ion, right? The sulfate ion, or the sulfate ion is what soluble, is insoluble. Sorry, it's insoluble. So if it was a sulfate ion that was present, it would have been what insoluble in excess dilute HCl, right? So, and it gives white precipitate. So here is going to be white precipitate formed. Precipitate is insoluble in dilute HCl. No gas detected. This is what you are going to write under your observations. Under observations, you write it under full observations. You copy what you have here inside your question paper. Observations. Then now inferences, guys. Inferences. This is it. You have the sulfate ions present. Insoluble sulfate, barium sulfate, because you are adding barium chloride. Guys, I'm sure I wrote all these equations, right? I wrote all the equations, so check out that video, guys. Then barium sulfate precipitated. This is the equation. This is the exact equation I wrote. This is it. No reaction of sulfate with dilute. That good. So guys, this is what we have. Okay, now what if it was a sulfite? Means we expect the sulfite to be what soluble in dilute HCl, right? In excess reagent. So we are going to come under soluble in excess dilute HCl. We have what still white precipitate formed. White precipitate formed in excess dilute HCl. Colorless pungent gas evolve. Right, colorless pungent gas evolve. Litmus paper red. It turns blue litmus paper red. Acidified dichromate. Good. So guys, so guys, let's see. I don't think. All right, good guys, good. So this is where we are, guys. This is where we are. So after having all these observations, now since it is soluble and it dissolves in excess reagent, so this is where we are going to have. We have the sulfite ions present. That's what I'm saying, that guys, your expectations are so important. If you've not watched the video I made on all these stuffs I'm talking about, guys, hurry check it out. It's going to improve your grade in paper 3. Remember that paper 3 in chemistry is a main factor that determines if you have an A grade or not, if you pass or not. Good. So this is what we have here. You copy everything, guys, everything under observations. Copy everything here. Then inference is likewise. You also copy everything. Copy all what you have here. Everything you have, everything. You copy everything. This is it. You have S sulfide ions present, insoluble sulfide, that. You just write everything, okay? This downward arrow, guys, simply means that this guy is a precipitate, okay? It does not dissolve. That's the essence of this downward arrow here. All right, guys, I think we have talked about that for the I think we've talked about that for the inorganic reactions, right? Let's now talk about the organic reactions, guys. Let's talk about how to use this same inference booklet to test that for organic reactions. Now let's say okay, now in this case I'll simply open to where I have organic reactions, guys. Good. This is where I have them. That's the third sample, this third source sample. This is it. This is where I have it. Then it continues here as well. So guys, let's assume that let's assume that I want to test for phenol. Good. So guys, I don't know if I'll make a video on phenol. I don't know if I'll make a video because it's also important. Or 2,4-dinitrophenylhydrazine to test for aldehydes and ketones, or test for the carbonyls. So let's assume that we want to test for phenol, and the equation is asking us to add about 2 cm cubes of neutral iron 3 chloride. Neutral iron 3, guys. So we'll simply look for where we have iron 3 chloride. This is it, guys. I think this is it, right? Iron 3 chloride, then in bracket neutral, right? So I'm expecting, my expectations, guys, that's what I'm saying, that expectations are so important, because I expect to see what? I expect to see a violet coloration or a purple coloration when I react this neutral iron 3 chloride with a compound that has a phenol, right? Or with phenol itself. So, and the page here is page 115. So I'll open to page 115. So guys, as you can see, this is page 115, right? I'm looking for where I have purple coloration or violet. Good. If it is phenol, so I'm seeing a red coloration. These are observations. If I had a red coloration, that's something that is not the phenol. I had a red coloration or a brown precipitate on boiling. I'll simply, these are my observations: red coloration, brown precipitate on boiling, salt of lower, this is it here guys, you have salt of lower aliphatic organic acids. Guys, maybe I should bring it up. You have salt of lower aliphatic organic acids present, e.g. you have the ethanoate or methanoate precipitation of basic ions to that. This is your inference. You end there. Then if it was a yellow precipitate that was formed, or a yellow solution, no precipitate, you say yellow solution formed. That is going to be your observation only. Then now you say salt of hydroxyl aliphatic carboxylic acids present, e.g. you have that. You copy everything. Then the same thing. Now guys, this is what I'm talking about. You have blue stroke violet coloration. This is for phenol, guys. This is for phenol. This is what you should know. It's so important. If the compound, organic compound, was phenol, right? Once you see blue violet coloration, you simply come under your observations. Violet coloration or blue violet coloration observed. Inference, phenol or derivative present, e.g. you have phenol 2-hydroxyl benzoate. That's the other name, formation of that. So guys, this is where I'm going to write. Then now, what if the question wanted you to add PCl5 or phosphor pentachloride? You simply open to where you have it. This is it here. You simply check. User, unfortunately, this book I have here, it is not too clear. Okay, so you do the same like what I've said here. So guys, if you not like the video at this point in time, guys, hit the like button, subscribe to the channel for more updates, subscribe to our channel, guys. And please, if there's something you're not understanding or you didn't get it so clearly, just put in the comment section and I'm going to reply to it as soon as possible, guys. As soon, within the shortest possible time, I'm going to reply to it. Okay, good. Then now let's look at the iodoform test. Iodoform, let me go to the content page again. Let me go to the content page, guys. I'll go to the content page and let's refer for me. All right, this is the content page. Good. What do you want to do the iodoform test? As you know, iodoform is used to test for ethanol, methyl ketones, and what, guys, and secondary alcohols, right? Good. So I'll simply, an iodoform, as you know, is a mixture of sodium hydroxide and what, iodine, right? Or sometimes you can also have other substitute apart from sodium hydroxide. Good. So guys, as you can see, this is let's look at it. All right, good. I think this is it, guys. I think this is it. We have iodine solution stroke sodium hydroxide or sodium carbonate solution iodoform reaction. Good. So we are put to page 16. Good. Page 116, sorry, page 116, not page 16, guys. 116. Good. So as you can see, this is it. I have a iodoform test. This is it. Now this is the table of observation. Now, an iodoform, guys, I expect to see yellow precipitate if all the compounds I listed, namely ethanol, methyl ketones, secondary alcohols, secondary alcohols are present. I expect to see a yellow precipitate formed. So this is it. I have yellow precipitate formed, may need warming, and septic smell. Good. This is the observations. You write it under observations. Then inference is you do the same. Okay, you do the same. You copy everything, the equation. Good. So guys, don't forget to like the video, guys. Subscribe to the channel for more informations. If you have any question, as usual, guys, leave it in the comment section. I'm going to reply to it immediately as soon as possible. Thank you for all those who were so patient to watch the video from start to finish, and I wish you guys good luck as you prepare for your exam. Visit our channel. We have so many contents in biology, chemistry, physics, mathematics, further mathematics, and so on and so forth. We have so many, guys. Explore all of them and pass your exam. That's our principal aim. Good luck to you, stay blessed, and have a great day.